Hello.
How are you, my friend?
Hello. Hi, how are you?
Yes, let's start. I don't have electricity. My battery might run down
Mm.
very soon. Yeah, how it goes.
Is it load shedding?
Electricity. I think they are fixing that transformer. I'm not sure what is happening around. It's not load shedding.
Oh, yeah. Okay.
All right. So all the questions have been attempted except for number. All the questions now, all the recordings are available
Mm.
except question number
Is it 5?
4. So
4. Oh, yeah, number
it's
4.
5 we did.
Yeah, 5 we did, yeah.
It's only 4, which is so the question is saying consider a rectangular loop with two sides as 10 millimeters and 20 millimeters respectively, and has a resistance of 20. Is that one a milliohm or a mega ohm? How do you know that it's a milliohm or it's a mega ohm? The resistance, how will you know that it's a milliohms or it's mega ohms?
I'll just assume because there it says millimeter. So I'll just assume it's a milli.
And how
In
will you know it's a ohm? The difference between milli and mega, how do you know?
I guess the mega will have a capital letter M.
Okay, yes. So because it's a small letter m, which means it's a
Yeah.
milliohms. So that loop with two sides is 10 millimeters and 20 millimeters respectively, and there's a resistance of 20 milliohms that rotate at 1000 radians per second in an uniform magnetic field. So we've been told that this magnetic field is only in the what? In the y direction. So magnetic field given by the letter B, magnetic field given by the letter B. So the magnitude of that component, remember B is a vector. Magnetic field B as a vector is equals to, so the component of the X is 0, the component of the Y is 10, the component of the Z is 0, and then the units are Weber, WB, it means Weber per meter square. So which means the units in Webers for magnetic field. So that WB is representing Weber. WB, that is the unit for WB in Weber per meter square. So if you have been given your units per meter square, which means automatically you must convert everything. Millimeters, you convert to what?
To meters.
Meters. Then this 20 millimeters, you also convert again to meters before you calculate. So calculate the induced EMF. Okay, here we want to calculate the induced EMF current. The induced EMF current using the formula for magnetic field. So we've been told that you need to consider the projected area normal, which means it's perpendicular to the field, perpendicular to the field, and assume that the rotation axis is identical to one of the sides. So basically, we just need the formula to deal with this problem for magnetic field. you must have a formula which we are going to be using for magnetic field. So number number 4. So we are calculating the induced current. Induction with the rotating loop and a nearby wire. So rotating rectangular loop, which is measuring 10 millimeters by 20 millimeters. So 10 millimeters is the same as 10 millimeters is the same as 10 times 10 to the power negative 3 meters, which is the same as 1 times 10 to the power negative 2, which means 10 to the power negative 2, it's 2 zeros, which is the same as 1 times 10 to the power negative 2 meters.
Yeah.
Which is the same. So we have converted. If you want to write as a decimal, 0.01 meters. You do the same for 20 millimeters, it will be just 0.02 meters. So we want the area. So remember, when you are calculating area, it's 1 times 10 to the power negative 2 times 2 times 10 to the power negative 2 meters. So the area of a rectangle, remember it's a rectangular loop, which means you're multiplying. So the area to be 2 times 10 to the power negative 2 meters, which is the length. So we are having the width of the rectangle, and you are also having the length of the rectangle. Then you calculate the area. So this is the width, this is the length. Any question there so far? In terms of, so if you are told calculate the area, so which means you're multiplying the dimensions. 1 times 2 is 2. 1 times 2, this 1 times 2 is 2. 10 to the power negative 2 times 10 to the power negative 2, you get 10 to the power negative 1.
4.
Meter times meter, you get meter square. Any question there?
So that is our area. The
That is
2.0 times 10 to the power negative 4 meters squared.
2 times 10 to the power negative 4. Square meters. Remember, in meters, square meters, because our magnetic field was Weber per meter square. So if we are having Weber per meter square, we can't work in millimeters. We have to work with units which are going to cancel, which are meters. Going to cancel, which are the meter. Then our resistance, we are told that the resistance is 20 milliohms. So 20 milliohms, it's 20 times 10 to the power negative what? 3. So you simply get 0.02 again. 20 times 10 to the power negative 3 milliohms. It's just 20
divided by 1,000
times 10 to the power negative 3, which is the same as what? 2 times 10 to the power negative 2, which is 0.02 ohms. 0.02 ohms. Others, the two are just placeholders. So we have converted those to ohms. So that is the key thing to do. You must convert your units to SI units, which is the standard units. Meters, millimeters, you convert it to meters. Then you are having milliohms, you convert them to ohms. That's all. Then from there, it's a matter of just substituting the formula the magnetic field B, and that B in bold, I told you it's a vector, isn't it?
Mm.
They always want to trick you by not putting the arrow so that you think that it's a scalar quantity. Then angular speed, we were told that the angular speed W is rotating at 900 watts per second. 900 watts per second. Any question?
Mm-mm. I don't have a question.
So now so if you want the flux is given by the magnetic field multiplied by A cos omega t. That is the formula for flux. Any question there for just the formula for flux? Remember here we are calculating the induced what? Induced current, the current induced. So we can relate, since we are given B, which is the magnetic field. A, what is A representing?
Area, is it?
Yes, the area. A is the area. And B is representing what?
The
What?
vector, what the 10y, the uniforms.
Weber, yes, which is the magnetic field. That B is the magnetic field, which is 10 Weber per meter square. So you replace, you substitute all your values. Angular speed or angular velocity or angular speed is 100, 1000 radians per second. We are given this one. And it's only moving in the y direction, which is a 10 per meter square. Any question?
Mm-mm.
Right. So the induced EMF at any given time, the induced EMF at any given time. Remember the EMF is this one, the formula for the magnetic flux, given by B, which is the magnetic field, multiplied by the A, you said is the area cos omega t. So if I want to know the induced EMF, it will be now the absolute. Those brackets, they're indicating it will be the absolute. If you get a negative, since EMF cannot be zero, negative zero, always positive, that's why we are saying absolute value, which means it must be a positive if there is a negative there. So it's a negative, differentiating the flux with respect to time. So let's differentiate BA cos omega t. What do you get with respect to time? We are differentiating it with respect to t. What is the derivative of
Mm. The BA
so
is the constant, right?
BA is a constant.
So it's gonna be um. Firstly, you would do the cos, which will have which will change to sine, and then you derivate the one inside the bracket. So it's gonna be sine wt multiplied by w, and then you.
When you differentiate it,
What about the negative? Are we not supposed to have the negative sign for the sine x, for sine?
no, first, what is the derivative without the negative first?
The derivative of cos is sine wt, and then multiplied by
A
w.
A,
Hmm?
BA cos omega t. What is the derivative of BA cos omega t?
Is BA sine
Mm.
omega t multiplied by omega.
It's going to BA.
Sine WT
Yes.
multiplied by
Yes.
W.
Oh.
It's wrong.
Mm. Repeat again.
It's gonna be you will start by taking the constant outside, ne? Which is BA. And then we're gonna have the derivative of cos
Yes, I'm saying you're differentiating
BA.
BA cos omega t.
So the derivation of constant is 0. Man. The answer is going to be BA. Ne? And then the constant, you're going to leave it. And then sine bracket WT multiply by the one inside the bracket W. Yeah, that's what I got. So it's gonna be BA sine omega t inside the bracket multiply by omega. Is it still wrong? Hello? Hello?
Hello.
Yeah. Oh, I thought maybe your phone died or something. Since you said you didn't
No,
have battery.
no, I'm still there. There's still some battery.
Okay,
So
so I
once you
was my answer.
from the formula, your formula there's always a negative because voltage can never be a negative. Remember, voltage must be positive. So that negative is compensating or it's going to multiply any negative answer of that cos. The derivative of cos
Mm,
is negative sign.
mm.
It's not sine minus sine omega t. So minus sine omega t, and already so what was your answer? I want to hear your final answer now.
My
You said
answer
the
was
final
BA, ne, which is the
mm,
constant, multiply by
mm,
sine of bracket omega t multiply by omega.
multiplied by omega because you also differentiate. It's
What
chain
is it?
rule, isn't it?
Yeah, it's chain rule.
Yeah, chain rule, which is correct. So when you differentiate the negatives, instead of negative sign, the negative had been cancelled by the one which they are just putting. So it will be
One on the
minus. Mm.
what is it? The D flux over the T. What is that symbol for?
We call it defy. It's for
Defy.
magnetic flux. Yes,
A.
phi is 10 magnetic flux.
So I want to ask something, ne?
Phi
If it
is the
happened,
magnetic flux.
oh, that formula for magnetic flux, it doesn't change. It's always cos.
I given absolute, meaning you are going to get a negative. So the negative of that to make it positive, because this E of that battery is going to be positive. You can't have a negative value.
So the formula for flask, is it always like that? The BA cos omega T.
Yeah, the formula remains the same.
Oh, so there's no way we
The
can
formula,
have a negative answer because we always derive it to be BAW sine W naught or WT.
cos, yes,
Oh,
it's because of the cos. The cos give you a negative, so you can't have a negative voltage.
okay.
Yes. Once you have your flux, you can calculate flux, which is BA, which is 10 multiplied by the area cos what? Omega T, you know, omega, it's now 1000 radians per second, which means it's 1000 T. So now we need to calculate the peak EMF. Remember the question was calculate the induced current. So we are not yet done. We have not calculated the induced. The peak EMF, remember that one was just the EMF of that battery at any given point in time. E naught ET is given by BA multiplied by omega sine omega T. So now, if you want to calculate the peak EMF, it's B omega EMF is BA omega. That is the peak EMF without the sine omega T. Can you see it?
I can't see the notes.
Is the screen not sharing now?
It's sharing, but it has rotated to.
Okay.
It's
How
giving
about
the
now?
triangle vibe. It's not straight.
Oh, it's not straight.
Mm.
How about now?
It's still the same.
Nothing.
Mm-mm. Nothing still.
You mean the north
Yeah, it's fine.
or what? It's
Yeah.
fine. So the peak EMF,
Mm.
remember the sign, when the sign is peak, sine omega T will be 1, isn't it? So
Mm.
at the peak, that's where sine omega T is 1. So which means BA omega times 1 is just BA omega. That is the peak EMF. When sine is at its max,
Mm.
sine omega T will be having an equivalence of 1, the peak EMF. This is the peak. For a sine graph, the peak is at 1. For the it cannot be negative voltage. So the peak EMF is a positive. So B, we calculated our B was the magnetic field, 10 Weber per meter square. That was our B, 10 Weber per meter square, which is B. The area we calculated, it was 2 times 10 to the power negative 4. 2 times 10 to the power negative 4. Those factorials are not there. It's just 2 times 10 to the power negative 4. Multiplied by the, that one was the area, multiplied by the omega, which was 1000 radians per watt a second. So multiply that, you are going to get 2 volts, which is the peak EMF. So for us to calculate the induced current, it only occurs there while we are having that peak EMF. So which means I of t is representing the induced current. The induced current, I of t, is given by, remember from the formula for voltage, what is voltage equals to? We at metric level, we used to say voltage is equal to resistance times what? Times current. So if I want to solve for current, current will be equals to what? Current will be equals to
V over R.
voltage over what? Over R, which is the same, that is EMF, which is the E, over the resistance, which is what? Which is R, which is that resistance over R. Any question?
No, I think the trick was just to find the voltage.
Yes. Once you know the voltage, then everything comes out. So
Mm.
we are solving for I of t. We are not solving for the peak current. If you are solving for the peak, then you are going to use E naught. But in our case, we are not using E naught. We are using E of what?
Of
E of
T.
t. E of t, which is sine omega t. Sine omega t. So it's just a matter of replacing the values. BA omega, we are having omega. The B is 10. The area is what? So we already calculated the value of BA omega, which is the peak. This is the peak, which is E naught. We already calculated BA. That is the one which we said is 2 watt, 2 volts. So this is the one which we are having here, the 2 volts. Which is on the numeric.
I was not hearing you,
This is the
sir.
2 volts.
The network was off.
No, okay. I'm saying, since we are using E of t over R, that BA omega we calculated, that is the peak, is the peak EMF, which we already calculated above, which is equivalent to 2 volts. So that is the 2, which is the divided by the resistance. Resistance was 20 milliohms. 20 milliohms is just 0.02 ohms. Sine omega t is your sine bracket omega t, which means omega was 1000 radians per second multiplied by t. So the units are amperes. That's why there's a A there. So the induced current which we are calculating is this one. That is the induced current, which means it is 100 sine omega t. So the value for everything after we've solved divided by the resistance, it will be 100 sine 1000 T amperes, which means the current is changing with time. At any given time, the current will be having a different value. It's no longer constant. That is the induced current, which means it's changing with respect to time. It's not only constant throughout the circuit. Any question?
The question that I have is, I can see that when you calculating the current, ne, you have added the sine omega t. So is it only one at the peak when we are looking for the EMF only for the voltage? Is sine omega t only one? It's one only when we are calculating the voltage, the EMF at the peak.
Yes. It's one at the peak. That's why
Oh.
we are saying at the peak, it's one. That's why we replaced the sine omega t, which means that graph of sine at the peak, we know its value. At the peak, it will be one. At the peak, it will be one. So I can calculate that BA omega in terms of values. But because I want the induced current at any given time, t, that's why you are expressing the current as I of t is
Mm.
equals to 1 sine omega t, which means it's as a function of time, which means if time is 2 seconds, I will have a current which is corresponding to time at 2 seconds. If
Mm.
time is 50, etc., etc.
So if in case they say you must find the time, or maybe if you are given the time, you just insert the time there.
It will be just reversing the order, yes, playing around with the equations,
Oh,
making t form of this.
okay.
All right. Then now we are going to B. So for A, we are done. Then B is saying what? We need to calculate the mutual inductance, M. Need to calculate that mutual inductance, M, in terms of the amplitude, in terms of the current amplitude, A, in the conductor, and the induced EMF in the loop. So that's what you want to calculate. The mutual inductance. Remember, the mutual inductance is represented by M, the formula for the mutual inductance. All right. So a straight conductor driving through a square loop, if the straight conductor current is I of t, it's A sine omega t. We've already calculated it. A is the amplitude, which was 100, sine 1000 t. The induced EMF in the loop, induced EMF in the loop is given by. So this is the induced EMF in the loop. Remember, we want to calculate the induced EMF and the mutual one, inductance. So this is the part for the induced EMF. It's given by minus M di dt, which means you are differentiating time. I mean the current with respect to time. So the M is the one which they are referring to as the mutual inductance, which they said calculate the mutual inductance. And also calculate the induced EMF. Here we started by the induced EMF. So this one is the mutual inductance. M is your mutual inductance. So whenever you see M, you know it's the mutual inductance. And how do you relate this EMF to the mutual inductance? So that EMF is not only in terms of when you are differentiating the magnetic flux d phi dt. We are not only differentiating d phi dt, the EMF can also be related by minus m di dt, which means I is representing the current. So you differentiate the current with respect to time. So in our case, what was the current? The current was what?
It was 100 sine 1000 something.
100 sine omega watt, omega t. So which means M is actual inductance. So when you differentiate A sine omega t, which means you are going to get, when you differentiate sine is just a positive cos. It means cos omega t. Because of chain rule, you also differentiate what is inside the bracket of cos, which means the omega will also go out. So that's why it's now, after you differentiate this one, di dt, you are going to get omega A cos omega t. The mutual inductance is a constant sitting on the left, sitting on the left. So now we want to calculate. And remember here, the instruction was saying, calculate the mutual inductance in terms of the current what? Amplitude A. It did not say replace the values. Okay? In terms of the current amplitude A in the conductor and the induced EMF in the loop. So first we calculated the induced EMF in the loop, which is this one. It sounds very easy, but to remember these things in an exam, find out sometimes it's not easy. That's why there are those marks. So EMF is equals to minus M, which is the mutual inductance, times the derivative of the current with respect to time. Then you get your induced EMF, E of t, not the peak EMF. Then if you want the mutual inductance, you are now making M subject of the formula. The mutual inductance. You are now making M subject of the formula. And when is cos at the peak? The peak of cos. When do we find the cosine graph at the peak? What would be the value if the cosine graph is at the peak?
Is it 1? Is it 0? 0.
Is the peak of a cosine graph. So the peak is where? Peak of a cosine graph. The peak of a cosine graph.
Is it at 90?
Is that what?
90.
Which is this point. It's negative what? 1. The peak, the maximum. The peak. For cos, for sine, remember we said the peak upwards. Then the peak for that cos sine graph. Remember it starts at 1 upward, then it goes down. So there it's negative 1. So instead of saying cos omega what? T. We are replacing cos omega t with what?
1. Minus 1.
Not 1.
Minus 1.
Minus 1. We replace with minus 1, where there's cos omega t. And because you are using the peak EMF, which means the peak, instead of ET, you are replacing ET with what?
E
The
naught.
peak, yes, peak EMF is equals to negative times negative is positive. So which means it's M omega A. Then you make M subject of the formula, which is the mutual inductance. So we are dividing both sides by omega A. omega A. So come we arrive here. This is the mutual inductance in terms of the amplitude A. So in your answer, they want to see this amplitude what? A. They don't want to see you replacing the values, just in terms of the amplitude. Any question?
My question is the mutual
Mm.
inductance. So when I'm looking for the mutual inductance, the
Mm.
I just know that I have to derive with respect to I have to derive the differentiate the value.
If you are looking for the mutual inductance,
Yes.
yes, but you'll be multiplying the M by di dt. And remember, the first one, when you're calculating the EMF, given what? The magnetic flux. Can you see the formulas are different?
Hmm.
Mm. So we are calculating EMF using the magnetic flux. The EMF using the magnetic flux. So you know the peak EMF is B A omega. So which means if you know the magnetic field B in Weber per meter square, you know the area of the loop and the rotational speed, which is 1000 radians per second, which means you can calculate the peak EMF. And remember, for this one, we are differentiating the magnetic flux, which is d
Hmm.
phi. That symbol which we're asking for is d phi. We have theta, phi. So this one, we call it, that Greek symbol is phi. So d phi, then since this at peak is a positive one, and then you replace, instead of ET, you're putting E naught. Then it will be BA omega, which is this one. E naught is BA omega, and everything you just substitute. The peak EMF is 2 volts. Here, the peak EMF was not 2 volts, but the peak EMF was minus MA omega. It will be now positive, since cos omega t will be now positive. So it will be negative, negative, then it give you positive. E naught is the same as M omega A. Then you make your mutual inductance subject of the formula by dividing by omega A both sides. Then you get your mutual inductance.
So that that with the I is the one that we found when we calculated the
The
current,
current,
the IT or
as for the current, for the DI, for the current. Any question there?
the question is that formula for mutual induct, is it always like that, or it depends on the question that we were given before? If for
No,
example to
it's
calculate the
always,
voltage, it's
it's
always like that.
always, yeah,
Oh,
E minus MDITT. That is the mutual.
I know, then I don't have a question if it's like that.
All right. So next week we are working on 2023.
Or on this one we don't have another 2024. Check. Was it only one?
I will check. I didn't know that they bring twice. I don't know.
I heard there's that one year for January and February for supplementary, and then we have the final one. I'll also check.
Okay. You just send me which one you want to work.
Mm. So I have a question, eh? As I'm I'm practicing some of the questions that I have, some of the solutions that I have questions. Do I just screenshot where I want to, where I'm looking for clarity?
Yes.
Send it to
No
you.
problem. Yeah.
Okay, no problem. Then bye.
All right. Yes.